Hi everybody. In today's lecture we are going to study about determinant. In that first we study about determinant of order 2. That is, we have to find the determinant of order of matrix 2 by 2. Let A is equal to A11, A12, A21, A22, which is general matrix of order 2 by 2. Then determinant of A denoted by mod of A, or determinant of A is equal to mod of. In determinant we write a straight lines. Okay, in in matrix we denote matrix by square bracket or round bracket. Okay, in determinant it is straight line. So we have to find the matrix of a determinant, and determinant value is always a single value. Okay, so here our calculation will be A11 into A22, which is multiplication of diagonals, A11 into A22 minus A12 into A21, which is our determinant of A. For example, if we consider a matrix A is equal to 1, 2, 3, 4, then determinant of A is equal to, or mod of A is equal to matrix of 1, 2, 3, 4, which gives us as 1 into 4 minus 2 into 3, which is equal to 1 into 4 is 4 minus 6, which is equal to minus 2. That is, determinant of A is equal to minus 2. Okay, so this is a matrix, this is a determinant of order 2. Next definition is determinant of order 3. So in this we consider a matrix of order 3. Let A is equal to matrix, general matrix we write here A11 into A11, A12, A13, first row, second row A21, A22, A23, and third row A31, A32, A33. Okay, so now determinant of A is equal to mod of first row A11, A12, A13, second row A21, A22, A23, and third row A31, A32, A33. Okay, this is our matrix of order 3. Here we have to find a determinant of order 3, and determinant is calculated for only square matrix. Okay, so here determinant will be in the form, here A11 into multiplied by determinant of, now if we cancel first row and first column, remaining terms will be A22, A23. Okay, this will be first row, and second row will be A32, A33. Okay, if we cancel the first row here, first row, okay, and first column, so remaining terms are A22, A23, A32, A33. Okay, so we have to multiply A11 here, A11 with A2 remaining terms of a row and columns. Okay, second will be minus, here first row second element is A12. Okay, so we have to delete first row and second column. So here we have a determinant of, we have to delete first row and second column. So here remaining terms are, now remaining terms will be, which are the remaining terms? First columns, second element A21 and A23 for first row, because we have deleting second column, A31, A33, A31, A33. Okay, we have to delete first row and second column, and last term will be plus. Now here it is A13. Okay, and we have to delete now last column. So remaining element will be, we have to write multiple of A13. Determinant of A21, A22, A31, A32. Okay, this is our last calculation. Okay, and after solving this, we get a single value which is will be determinant of A. Okay, so you can further calculate it also. A11 into A22 into A33 minus A23 into A32 minus A12 into bracket A21 into A33 minus A23 into A31, and plus last term A13 into bracket A21 into A32 minus A22 into A31. Okay, this is our determinant of A. Okay, so now we take an example related to determinant of 3, order 3. If we take an example as A is equal to matrix 1 0 3 2 minus 1 1 3 0 1. Okay, so now determinant of A is equal to determinant of A, here we take it as minus 3. So in term calculations will be some changes. So here 1 into determinant of minus 1 1, we have to delete first row and first column, so it will be minus 1 1 0 1. Okay, minus 1 1 0 1 minus, here it is 0, so 0 into anything is 0, so it is not necessary to do calculation for second, and plus minus, it will be minus 3, or you can write it as plus into bracket minus 3 into determinant of, we have to delete first row and last column, so terms will be 2 minus 1 3 0. Okay, 2 minus 1 3 0. So we do here calculation, which is 1 into any time is that term only, so here not necessary to write outward 1. So minus 1 into 1 is minus 1, minus 1 into 0 is 0. Okay, so first bracket 1 into bracket minus 1 minus 0. Okay, second term is 0, we delete it from here, plus minus, it will be minus 3 into bracket 2 into 0 is 0, minus, we write here minus, and minus 1 into 3, which is minus 3. Okay, in determinant when there are negative signs, please do the calculation clearly, because there are many sign changes, so do it very neatly. So here it will be minus 1, first term minus 1 minus 0 is minus 1, here minus 3 into bracket 0, minus minus, it will be plus 3. Okay, 0, here minus minus, it will be plus, 0 plus 3 is 3. So we get here minus 1, minus 3 into, here 3 into 3 is 9, and outward sign is minus, so it will be minus 9. So our calculation is equal to minus 10, which is our determinant of A. Okay, this is our determinant of A. Okay, now next definition is singular and non-singular matrix. Now singular and non-singular matrix are dependent on determinant of a matrix. Okay, its definition is a square matrix. A square matrix is called singular matrix is called singular matrix if determinant is 0. Determinant is 0. Otherwise, it is called non-singular matrix. Otherwise, it is non-singular matrix. Non-singular matrix. Okay, that is when if A is a square matrix, if determinant of A is equal to 0, then A is singular matrix. Singular matrix. And if determinant of A not equal to 0, then A is non-singular matrix. Okay, these are the definitions of singular and non-singular matrix. For example, we can take it as, for example, if A is equal to matrix 1 minus 1 2 2 2 minus 2. Okay, we have to check whether A is singular or not. Singular or not. Okay, so in this example we have to find a determinant of A. So determinant of A is equal to mod of 1 minus 1 2 minus 2. Okay, which is equal to 1 into minus 2. 1 into minus 2 is minus 2, minus of 2 into minus 1 is minus 2, which is equal to minus 2 minus minus plus 2, which is equal to 0. Therefore, here determinant of A is equal to 0. Therefore, A is singular matrix. A is singular matrix. Okay. Now next consider example as if given A is equal to matrix, second example, A is equal to matrix 1 3 2 minus 2. So we have to determine it is singular or not. Singular or not. Okay. So we find determinant of A is equal to mod of 1 3 2 minus 2, which is gives us as 1 into minus 2 is minus 2, minus 3 into 2 is 6, which is equal to minus 8. Okay, so here it is determinant of A is equal to minus 8, which is not equal to 0. Therefore, A is non-singular matrix. A is a non-singular matrix. Okay. So these are the examples related to singular and non-singular matrix. Remark is, if determinant of A is equal to 0, that is, it is singular matrix, then A inverse does not exist. Okay, determinant 0, then A inverse does not exist. If determinant A not equal to 0, then we can find A inverse of that matrix. Okay. Now we see some of the properties related to determinant. In first property, determinant of triangular matrix and diagonal matrix is a product of their diagonal terms. For example, if we consider it as 1 2 0 0 minus 1 2 0 0 3. Okay, this is a upper triangular matrix as diagonal below entries all are 0. Okay, which is upper triangular matrix. If it is A, then its determinant of A, we doesn't need any calculation, we directly write it as product of diagonal entry, which is 1 into minus 1 into 3, 1 into minus 1 into 3, which is equal to minus 3. Okay, determinant A will be minus 3. If one of the entry will here 0, then determinant will be also equal to 0. Okay, for example, if A is equal to matrix 1 0 2 0. Okay, here diagonal above entries are 0. It is lower triangular matrix. Okay, so determinant of A is equal to product of the diagonals. Here diagonal entries is 1 and here it is 0, which is 1 into 0 will be equal to 0. Okay, so when the matrix is of the type triangular matrix, in which it is upper triangular, lower triangular, or it is diagonal matrix, which is scalar matrix. Okay, so when these types of matrix are given, then its determinant is product of their diagonal entries. Okay, we can do direct product of diagonals and we can write the diagonal determinant of A is equal to production of their diagonal entries. Okay, which is our first property. Second remark is, if a matrix A contain a row or column having all zeros in it, then determinant of A is equal to 0. That is, a matrix, if a matrix A has a column, one column 0, we write it as 1 minus 2 and its second column is totally 0. All entries in that column is 0. So determinant of this types of matrix is always equal to 0. Or you can consider a 3 by 3 matrix of as 1 minus 1 2 0 0 minus 3 0 and last row is 0 0 minus 0 0 0. Okay, here last row and last column are all entries 0, so we directly write determinant of A is equal to 0. We here do not need any calculation. You can directly write determinants of that type of matrix is 0. Next property is, determinant of A and its transpose is always equal. Okay, determinant of A and determinant of A transpose is always equal. Next property is, determinant of K into A is equal to K raised to n into determinant of A. Okay, it will be K raised to n into determinant of A, which n will be order of a matrix A. Okay, these are some properties related to determinant. Okay, lastly it will property only, we can say that only square matrix have a determinant. If you considering a rectangular matrix or which matrix square, which are not square matrix, then its determinant is not possible. Okay, only a square matrix determinants are possible, which we can calculate. Okay, so these are the properties of determinants which we are required for our next units in system of linear equation or in further calculations of next unit of linear algebra. Okay, so this is an important part of linear algebra. So today we stop here. Please see the examples related to singular and non-singular matrices also. Okay, so we stop here.